Let's move on to talk about vector product. So we are given the same vectors as the scalar product examples, but instead of finding a scalar product, now let's try to find the vector product. Again, we put the tail of both vectors on the origin. So the tail of vector A and the tail of vector B are all placed on the origin. And now we try to determine the vector product. For vector product, we determine the magnitude of A cross B using this way of writing. Okay, now if you notice this C here, the answer of A cross B, it's a vector. Previously in the scalar product, the result is a scalar. But now, because this is vector product, the result of the product is a vector. So there's a right arrow on top. And now because we are finding the magnitude only, we have to take vector C and modulus it. Then by putting a modulus, we are finding the magnitude of vector C. Okay, so magnitude of vector C is the magnitude of A cross B. And we can find the magnitude for A cross B by using the formula AB sine theta. Okay, so this is fixed. If you are finding a magnitude of A cross B, find it using AB sine theta. Magnitude of A, magnitude of B times sine theta. Again, the theta here represents the angle between the two vectors. In this case, it's 45 degrees. So again, we substitute in the value. Magnitude of A is 5 Newton. Magnitude of B is 3 meter times the angle sine 45 degree. Yes, as shown here. And we calculate the answer to be 10.6 Newton. Okay, so this is the magnitude. Again, if you want to rewrite it, you can also write it this way, because C here, you can think of it, it is actually representing the magnitude of vector C. Writing it this way is also representing the magnitude of vector C. So you can remove the right arrow and remove the modular sign. The two come in a pair. If you write the arrow, you have to introduce a modular sign. If you don't write the arrow, you don't have to introduce the modular sign. So doing it this way is accepted. Doing it this way is also accepted. So that's for the magnitude of A cross B. But again, A cross B is a vector product. The result is a vector. So besides having magnitude, we should also have direction. But for the direction of A cross B, the direction is determined using the right-hand rule. So let's try to determine the direction of a vector product. So we'll be using back the same example as just now with vector A and vector B with an angle of 45 degrees between them. So let's say today we want to find the vector product of A cross B. In this case, how do we find the direction? Okay, with the magnitude we've discussed in the video just now, so we'll be focusing on the direction. So to determine the direction, first we take our right hand. We are going to use our right hand rule or right hand palm rule. It depends on how you call it. Okay, so first thing we do is we align our fingers together with the direction of the first vector. We write here our first vector is A, right? So we align our fingers parallel to the first vector. As you can see here, the first vector is A, so I'm aligning my hand parallel to A. Okay, there's two ways of aligning your hand. One is you aligning like this. Okay, the other one is align them like this, right? Okay, both of them, your fingers are pointing in the direction of vector A. Okay, but how should you position your hand is the palm of your hand, which is this one, the palm of your hand should be facing B. So B is over here, right? So your palm of your hand should be facing B. Okay, again, your fingers should be aligned with A, while your palm should be facing B. So this way it's wrong because B is not there. B is not there, B is over at this side. So we align our fingers with our palm like this. Okay, that's the first step. The second step is we swing our fingers from A to B. Okay, so this is A, this is B, right? We swing our fingers from A to B. We are able to swing smoothly, right? If you are able to swing smoothly from the first vector to the second vector, that means we position our hand correctly already. So this is the correct positioning of hand, and by positioning our hand like this, we are able to determine that the direction of the vector product is pointing into the page. Okay, it might be a little bit difficult to see why it's into the page, but as I swipe like this just now, right? As I swipe like this just now, my thumb will be the direction of the vector product. So if I swipe my thumb like this, my thumb is showing that I'm pointing into the page, pointing into the page. That's why the direction of the vector product here, it's pointing into the page. Okay, let's try a few other examples so that we are familiar with this right hand rule. Let's try the second example here. Let's say I have a vector f and a vector g. Then in between them, there's 50 plus 25 degrees, so 75 degrees in between them. So let's say today I want to find the vector product of f cross g. Let's say today I want to find f cross g. So how do I find it? Again, see what's the first vector. The first vector is f. So I align my fingers with the fingers aligning with the first vector, but my palm should be facing the second vector. So this is incorrect because my palm here is facing not towards the second vector. The second vector is g, is on the other side. So I should be turning my hand like this so that my finger is aligned with f, but my palm, this is my palm is facing towards g. Okay, so once we have done that, swing our fingers, check whether we are able to swing from f to g. So we are able to swing from f to g, right? We are able to swing from f to g. That means the positioning of our hand is correct. So our thumb is pointing where? Our palm is pointing into the page. That's why the direction of the vector product f cross g is pointing into the page as well. Okay, pointing into the page. Okay, let's try the third example. The third example here, I have vector m and vector n. So here, let's say I'm going to determine the direction of the vector product m cross n. Let's say I'm finding for m cross n, what should be the answer? Well, I'm looking for direction. Again, I don't care about magnitude, I'm looking for direction. So again, take out your right hand, align your fingers in the direction of the first vector. So the first vector is m, so I align my finger along with m. Then I make sure my palm is facing the vector here. Okay, as you can see, my palm is facing the vector n here. If I turn it this way, then my palm will be facing the other way around. So that's wrong. This will be right, because if I align it like this, my palm, I'm able to see my palm is facing this vector over here. The next thing that we check whether our fingers is able to swing from the first vector to the second vector. So let's try to swing. Swing. Well, yes, we are able to swing from vector m to vector n. If we are on the other side, we are unable to swing our hand. We are unable to swing our hand this way. Our hand really cannot bend that way, right? Okay, we are unable to swing that way. The only way for us to swing from m to n is to swing like this, naturally swing like this. Okay, so once we check that the direction of our swinging can make us go from the first vector to the second vector, the direction of our thumb will show the direction of the vector product. And the direction of our thumb is pointing out of the page. This is the page, it's pointing out of the page towards you, pointing out of the page. In this case, we will say that m cross n, the direction is pointing out of the page.